All right, let's get some help on 4-6, the practice problems with quantum numbers. In our first question, we're asked which of the following statements is false. First statement, the principal quantum number reveals a great deal about the electron's energy, as well as revealing the number of sublevels, orbitals, and total electrons found. Well, remember, the principal quantum number is n. The energy of an electron depends not only on the level the electron is on, but on what sublevel the electron is in. So the bigger your n value, the more energy the electron has. So yes, n, the principal quantum number, has a lot to do with the electron's energy. Remember that the number of sublevels on a given level equal n. So on the first level, there's one sublevel, it's the s. On the second sublevel, there are two sublevels, the s and the p. On the third, there are three, the s, p, d. On fourth, there are four, the s, p, d, and f sublevels. The number of orbitals on a level, is that revealed by the principal quantum number? It is. Remember, if you square that number, you know how many orbitals there are. So on the first level, 1 squared is 1. There's one orbital, and it is the orbital that makes up the s sublevel. The second level, 2 squared is 4. That's 4 orbitals. What are they? The 1s and 3 p's. 4 orbitals holds. Each orbital holds 2 electrons. So 4 orbitals on the second level would mean the second level has the capability of hosting or holding 8 electrons. We know it does. Second level holds 8. Now we know why. There are 4 orbitals. The total electrons on the energy level. Well, if we know the orbitals, and each orbital holds 2, if we take 2n squared, we know how many electrons that level could have potentially on it. Letter B, a given p orbital holds more electrons than an s orbital. No. All orbitals hold 2 electrons. However, the p sublevel holds more electrons than the s sublevel. Because if you remember the s sublevel, your L is 0, your second number is 0. There's only one orbital in the s. There's only one orbital making up the s sublevel. When you're in the p, your second number is a 1. The p sublevel has 3 orbitals, the -1, the 0, and the 1. In the 4-5 packet, you'll see when L equals 0, you are in the s. When you are on the s, there's one orbital. When L equals 0, you're in the s. How do you know how many orbitals there are? The other way of doing it is taking 2 times your L. 2 times L is 0, plus 1 is 1 orbital. There's one orbital in the s. There are 3 in the p's. When you're in the p, your second number is a 1. You could take 2 times 1 plus 1, that's 3. You could also figure out the third number. The third number would be -1, 0, or 1 when L is 1. It's -1, 0, or 1. So there's 3 p orbitals making up the p. So the p sublevel can hold 6 electrons. The s sublevel can only hold 2 electrons because it only has one orbital. Yet each orbital can only hold 2 electrons. Letter C, p orbitals on the third are shaped the same as the p orbitals on the second? Absolutely. All p orbitals have those shapes we were just talking about. All p orbitals have this dumbbell or hamburger bun shaped. The only thing that makes them different is the orientation of the p orbitals. They each are oriented. One's along the x, one's along the z, the other's along the y. They have the same shape, and on a given level, energy level, they have the same energy. What about letter D? The F sublevel holds more electrons than the D. It does. The F sublevel had 7 orbitals. How do I know that? Well, when you're in the F, your second number is a 3. Remember the formula. 2 times 3 plus 1 is 7. The D sublevel, when you're in the D, the second number is a 2. 2 times 2 plus 1 is 5. The D has 5. The F has 7. Here we are. Here's the 5 Ds. Here's the 7 Fs. The -3, -2, -1, 0, 1, 2, 3. Because when you're in the F, your second number is a 3. When you're in the F, your second number is a 3. When you're in the D, your second number is a 2. So what are the orbital numbers when you're in the D? -2, -1, 0, 1, 2. That's 5 numbers, 5 orbitals. Yet each orbital holds 2 electrons. So how many electrons does the F sublevel host? Well, there's 7 orbitals times 2, that's 14. How many electrons does the D sublevel hold? There's 5 orbitals. Each orbital holds 2. 5 times 2 is 10. So the F sublevel, every orbital holds 2. In the D sublevel, every orbital holds 2. But there's more orbitals to the F than there are the D. Letter E, the 5th energy level has a lower energy than the p orbitals on the 5th energy level. The s orbital on the 5th has lower energy than the p orbital on the 5th. What's the energy of the the s orbital on the 5th? Energy is n plus L. The n is 5. What is the L when you're in the s? The L when you're in the s is 0. 5 plus 0 is 5. What's the energy of the 5p? Well, the energy is n plus L. The n is 5. When you're in the p, your L is 1. 5 plus 1 is 6. Where do I get those numbers? How do I know the second number L is 0 when you're in the S? The second number is 1 when you're in the P. How do I know that? It's right in your notes. If you look right here, when you're in the S, your L is 0. When you're in the P, your L is 1. You don't have to memorize those, but you need to know what they mean. Let's take a look at 2 through 6. If there's a number wrong, you're supposed to highlight it. 4, 3 minus 4 plus half. That's not possible. The third number cannot be a greater value, a greater absolute value than the second number. If the second number is a 3, the third number can only be -3 to +3. It can't be a -4. What about a 3, 3 minus 2 minus half? No, no, no. The second number can never be the same or bigger than the first number. The second number is 0 to the first number -1, n minus 1. So if the first number is a 3, 3 minus 1 is a 2, so it can only be a 0, 1, or 2. Oh my gosh, look on number 4. They started off the first number as a negative value. No, no, no. The first number can never have a negative value. The first number starts at 1 and goes up to 7, theoretically infinity. This set of numbers is actually correct. What's wrong with this set of numbers? The fourth number can never be -1. The fourth number can only be a -half or +half, as it is shown on 2 through 5. What numbers can we use to fill in the blanks? What can I fill in? This is a blank right here. If this is a 4 and this is a -3, this has to be a 3. Why? If this is a 4, then this could be a 0, 1, 2, or 3. But if this is a -3, that means this has to be a 3, because a -3 means that this number, a -3 mean, remember the third number is minus the second number to positive the second number. So if the third number is a -3, that means this has to at least be a 3. I have a 4, 3, and a -half. What's the first number have to be? The first number has to be bigger than the second number. It can never be equal or less than the second number. So if this is a 3, this could be a 4, 5, 6, or 7. And the only one there that's possible would be the 4. If this is a 1 and this is a 0, well, if this is a 1, this has to be a 0, simply put, because the second number is -0 to the first number -1. So if this is a 1, 1 minus 1 is 0. So it has to be a 0. Finally, what is the energy associated with the 4D? Remember, energy, you have to add the first two numbers, but they didn't give us the second number. They only gave us the first number. So the first number is a 4. How do I get the second number? Well, I'm in the D. If I look at my notes, if I'm in the D, I know my second number is a 2. So I come down here. Second number is a 2. 4 plus 2 is 6. The energy is 6. That's all there is to practicing with the quantum numbers. If you have any questions, don't hesitate to contact me to get additional help.